Thanks for joining us. This is the Automation World Get Your Questions Answered podcast, where we connect with industry experts to get the answers you need about industrial automation technologies. This podcast series is sponsored by Allied Electronics and Automation, carrying the most automation and control brand names in North America. Now, the questions posed in this podcast series all come from automation technology users across the process and discrete manufacturing industries. I'm David Greenfield, Director of Content for Automation World, and the topic for this podcast is how to configure a wireless network for mobile use. With more and more industrial companies opening up at least some portions of their operations to access by mobile devices, this is becoming an ever more important issue for manufacturing companies of all sizes. And joining me for this podcast is Justin Shade, Lead Wireless Product Marketing Specialist with Phoenix Contact, a supplier of multiple automation-related technologies, ranging from connectors and cables to HMIs and PLCs to sensors, power supplies, and industrial communication technologies. So, Justin, let's start by explaining what key elements are necessary in any industrial wireless network to enable it for mobile use.
Sure. It's kind of an interesting topic because when people look at the industrial wireless and implementing an industrial wireless network, they typically first go right to what product I'm going to use because that's kind of the end goal is installing that wireless product. But there's a lot of detail and information that they're skipping over if they're going right to the product. And I look at it kind of back to my third grade self when you had to do current events. So back in third grade, they give me this task: go to the newspaper and find a current event and do the who, what, when, where, and why. And that kind of translates over to the design and implementation of industrial wireless networks, knowing those important details. The who of who is going to be monitoring the system, who is going to be paying for the system, who is going to be approving the installation of the system. Because nowadays, when you're specifically looking at indoor applications and warehouses and material handling, you have your OT group who's wants to get this efficiency in all their processes, but you're also now merging over into that IT group who has always owned that space. So if you're not communicating with them, something that you may want to use may not be allowed to be in that facility. Likewise, who's paying for it? Is it going to be the IT group that's going to be approving the budget, or do you have your own budget with your OT team? So finding out those details to start, and then the what are you doing? What are you trying to do? What's your end goal of the system? I always say that there's not one size fits all of the wireless communication. Everything has pros and cons, ups and downs of what they can do versus what you expect it to do. So establishing what your goal is for the system first before diving into the product is important. The when, when are you planning on doing this? How is it tomorrow? Do you need something tomorrow, or is this a long-term project where you have a big facility that you're going to be network and planning, the conduit runs, the wire runs to the radios, to backhaul the information to your network, the placement, the contractors, the permits, all that information needs to be settled before you can actually, implement that project. The where, I think we kind of covered that one, but where are you going to place all the wireless nodes? Can you place them where you want to place them? I've been down many applications where, hey, we're going to put wireless nodes on these devices, and we want to be able to access them, with our tablets, and then come down to it, you can't put them there. So making sure you validate your locations of your wireless nodes. And then the why. Why are you doing it? People never think about why, because why comes back to the who and the what. Are you doing this just because you want to? Well, now your budget's a little lower because it's not an important aspect of an installation. Now you have to convince somebody that it's worth it. If it's mission critical, now the budget of the project and the timeline of the project tightens up, and the budget gets bigger because it's an important thing to somebody. Um, so it's interesting, an interesting way to look at it. Current events and the who, what, when, where, why. But before you start looking at anything from a product standpoint, you got to answer those questions and make sure you have those details ready to go, and then you can move over to what product technology I want to use, what type of product I want to use. Is it inside the cabinet, outside the cabinet? Um, and then for mobile use specifically, there are two main technologies today that you use for mobile technology, or mobile applications, and that would be Wi-Fi or WLAN, and Bluetooth. Um, so you know you look at what technology is allowed, what technology is there already, um, and making sure that again where you're putting it is allowed. A lot of indoor applications, like I mentioned, IT tends to want to own that space, and um, they have their enterprise-based products that they typically want to use, and sometimes they're okay to be in our industrial world, and sometimes they're not. But they want to have that grasp and that ownership of the floor. So um, it's important to kind of have that collaboration between the two groups, so you're both in an understanding of why you're doing it and what the end goal is.
Justin, you mentioned in your response there, you mentioned the issues that inevitably are created with, around industrial networking, especially with wireless, between the OT and IT groups. From your experience in industry, can you kind of say how this tends to work out? Is it something that becomes more in the realm of IT, or is it its uses on the plant floor? Does that stay with an OT? How is that typically handled or managed?
It's merging, definitely merging. My conversations are getting more and more involved with the IT groups, especially when it comes down to a WLAN installation. Historically, WLAN installations are owned by IT, and when the OT group wants to network up to an existing network or install their own network, I'd say it's 50-50 whether IT goes, you know what, you can connect to my network, and I'll segment you off, and I will give you your own pipe, or they go, you know what, you're not allowed to have Wi-Fi in this area at all. You need to find something different. And again, that comes back to the whole, let's talk up front, and that would be the biggest advice: is if you're going to be on a warehouse floor and you're going to network something, get them involved early, because they'll appreciate the fact that you are coming to them and not just doing something. And then that's because the worst thing you could do is install something and all of a sudden the whole facility is not working, or something's not working like it was before, and you have 5 or 6 guys coming down to the floor, knocking on your door and asking, what did you do down here? Because they're not getting data, or they're getting alarms and alerts that there's rogue devices on their floor. So in my experience, if you bring them in the beginning, they'll have their concerns. They won't know necessarily the industrial vendors. You know, the IT groups don't really know who Phoenix Contact is as a Wi-Fi vendor. But once we have that conversation and go, hey, we do everything you do, we just put in a different type of housing. They're typically understanding and go, okay, well, here's what you're allowed to do. Here's what we're going to do. Here's what you're going to do, and here's the box in which you can work. Um, and usually it's okay. But again, if you go the other direction and pull them in late, they tend to be a little less flexible.
Okay. Yeah, thanks for clearing that up. I know it's still very much a developing situation, so to speak, but it's always interesting to hear different insights into how this is actually playing out day to day in industry. So when we think about wireless networks in industry, often it's the first things we think about are, the use of, smartphones and tablets. But what about mobile assets like automated guided vehicles? Do they require a different wireless network configuration?
Yeah, I mean, it's definitely, well, it depends on how the guided vehicles and everything are set up. Um, Most of the time, with automated guided vehicles, there is some kind of computer or logic controller on board the AGV. So a lot of the times the wireless communication is just there to give status feedback, get a new command from the traffic controller, and but the AGV is really doing its process on its own. So when it comes to that kind of setup, um, you still would like to see an industrial rated radio because just from the form factor, the power input, its resistance, and it's designed to resist the vibration and the bumps and the movement of the guided vehicle. I still see today, more generic, off-the-shelf residential type radios and AGVs here and there. And from what I hear from those manufacturers, they tend to replace them here and there after every couple months because they're getting bounced around and banged around. Um, but as long as you're doing that type of communication, just hey, status in, status out, where are you, where are you going, here's your next task. um, the infrastructure behind it can be, you can use an existing infrastructure. um, if you have the ability to build your own for that network, it's always beneficial to do that, because now you're segmenting all the building or office traffic that is going back and forth, printers, emails, the YouTube videos that are flying back and forth from people going out on their lunch break that's traversing this network. You're getting that away from the production network that you have the AGVs on, and that just makes the pipe cleaner. Um, Sometimes that's available in new installations, new warehouses. That can be an option. Um, on older, existing warehouses and buildings where stuff's already there, it's a little tougher because uh, you know the system's already there and they don't want to invest in another system. Now, the network owner can do things like VLANing, and setting up certain channels to segment that AGV network from the IT network, and most of the time that's sufficient enough for what you're looking to do. But if your goal is to have real-time communication with those AGVs, where, hey, if I don't get some kind of feedback from this guy within 2 or 3 seconds, I need to stop that cart because I don't know what it's doing. Now that turns your whole use case for your infrastructure around, because now you need to make sure that connection is solid. You need to make sure that the pipe is big enough for your data when that data needs to go. Um, but most of the time, there's some kind of computer or something on board, so it's not as important to have a segmented network.
Okay, thanks for explaining that. When it comes to industrial networking protocols like Profinet or Ethernet IP or Modbus TCP, what sort of impact do they have on industrial wireless networks?
Anymore, not as much. It depends on what the technology of wireless you're using, though. So Modbus TCP is old faithful when it comes to an industrial protocol.
Mhm.
It's very robust, reliable. Compared to Profinet and Ethernet IP, it's slower, but it's very deterministic in the way it's communicating. So with the Modbus TCP communication, you can really use that across any type of wireless technology, whether that's a Wi-Fi technology, a Bluetooth technology, um, uh, a longer range proprietary, like a frequency hopping spread spectrum technology that's going long range, because it's not looking for data really fast. It's more of a, I want to hear your update, and if I get it in a second or two, I'm good. It's more of a monitoring and control type protocol. When you get in the Ethernet IP and Profinet, um, they're typically on a wired side. They're more quote unquote real time, where they're looking at 10 to 20 millisecond update times. You're talking to drives, and you're talking to motors, and you're turning VFDs on and off. So it, they tend to be a little more aggressive. But when you get into a wireless application with those protocols, again, you look back at what are you trying to accomplish? And most of the time, when you're looking at Ethernet IP or Profinet over wireless, you're doing the same thing you're doing with Modbus TCP. I have this cabinet of stuff, and I want to get online and I want to download the firmware of a new firmware update to the PLC, or I want to go in there and change the code and update something, or I need to monitor these inputs, and if they go high, I want to send this command. So again, the use case is if this happens, if I can update that in a couple seconds, that's fine. Or 100, 200, 300 milliseconds, that's fine. You never want to try to do real time communication over a wireless system because it's just not as deterministic as a wire. Um, so again, it comes back to that. What is your goal? What is your need for this system? And in my experience, with any industrial protocol, you're looking at 50 to 100 millisecond rates in most networks to be fairly robust and reliable. Whereas the wire, when you're on a wired network, you're looking at 10 or 20 millisecond update time. So it's a fairly big difference when it comes to industrial communication when you look at those protocols.
And does that with that gap or that difference between the wired and wireless, the millisecond response rate, does that pretty much require that you use wireless just for certain types of applications and not others?
Yeah, I mean, I would say, I mean, my job is industrial wireless. That's what I do. But I say, if you have the ability to wire something, if it's there, plug it in. I mean, it's
Mhm.
there for a reason. The network's there already. But if you're looking for real time communication between devices, unless you're very confident that you're going to have a robust, reliable signal between point A and point B, and it's not going to be interrupted, I tend to make sure you evaluate that a little further. Maybe do a test. Maybe do a long term test, a 30 or 60-day trial of your whatever vendor's product you're looking at uh, using. Get them to loan it to you for a month or so, and because you don't know, that's the thing with wireless. You can't see it. With a wire, you're kind of it's in quote unquote it's in the wire, so you kind of know what's going on to
Mhm.
the wire. In the air, you don't know it's there. You don't know if someone's going to turn on a hotspot at lunch and get their laptop onto their hotspot, and that hotspot turns on the same channel as your robotic arm is running on, and all of a sudden your robot doesn't work anymore. Um, you don't know if someone's going to install something else right next to yours. I mean, you hope you have a conversation, but it happens. People tend to turn things on, put things somewhere, plug something else into the switch that's going over the wireless network that you don't expect to be there. So when in doubt, plug it in. But if you have the ability with the vendor you're talking to get it for a month and just verify it, try before you buy. I mean, I love that concept because it gets the confidence of your integrator, it gets the confidence of your end user, um, and because they know that if it's not going to work the way they want it to, they're not obligated to keep it. More times than not, if you design it right, they're going to test it, they're going to try it, they're going to like it, and they're going to keep it. And it just opens that door to more opportunity that customer or that end user.
Okay. So just kind of going, continuing the same line of questioning there, what you've been mentioning there, where if you mentioned that if you have the opportunity to plug it in, that's the way to go is definitely to do that. So does that mean, from your perspective, that wireless is best reserved for things that are hard to reach or hard to get to, or rotating equipment, things of that sort that have historically been identified for wireless?
Yeah, definitely. I mean, nothing's changed on the use case for wireless. Things that spin, slip rings, rotating robotic arms with the flexible cable. Those cables aren't cheap, and if you look at where they're being used, it's applications where downtime costs hundreds of thousands of dollars, a day. So I mean, those are the applications where they're um, historically used. But people are finding ways to use wireless in places that haven't been used before. So we discussed the Ethernet IP profiling, that they want real time communication, but now they want to do it wirelessly. So when you have that conversation about, hey, here's what you are doing and here's how you're doing it, it's not going to work wirelessly just because of what your expectation of the network is. Um, Once you have that conversation and explain it to them, they can go back and evaluate their network and go, I don't really need to have it that fast, or I don't really need to have data that often, or I can live if I get a missed packet or two. Um, and again, this comes down to that's how they've always done it. They've never really evaluated it for a wireless system. Um, and it's not that it's wrong or it's right; it's just different. Um, and that's where we're getting to nowadays. I mean, there have been a couple applications I've worked on where um, it was a real-time communication application, and for all we could do with a Wi-Fi infrastructure, we couldn't get it to work. And the customer was frustrated, we were frustrated, and then we took a step back, reevaluated what is your goal, and the goal was to just gather data. It wasn't to have real-time communication. So we got some people in, we evaluated their code with them, found that they were just requesting data faster than they really needed it. So when they turned it down and moved it to a more realistic timing, everything ended up working. So again, it all comes back to that, sitting down with the user and going, what do you want this to do? What is your goal, and what is your expectation of the network once it's running?
Okay. All right. Thanks for clarifying that. So, when it comes to wireless or really anything based on or around Ethernet, security is always going to be a big issue. So, Justin, what are your recommendations for securing an industrial network when it comes particularly to wireless access?
Yeah. So exactly. So when it comes to the wireless security, it really comes down to um, what type of technology you're using. So there are some proprietary based technologies, wireless technologies that are inherently secure because they are proprietary in nature. So the ability to hack a network is very low. And when you look at those networks, if they even customer or user was even able to quote unquote hack a proprietary network, a lot of those proprietary networks are low bandwidth IO and serial data. So there's not a lot for them to see on that network. But when you move into the Ethernet-based networks, like a Wi-Fi network or a Bluetooth network, um, those are public technologies. They're driven by the IEEE, and the way the protocol works is published. So anybody can go out and find the information on how that wireless communication works. So it really comes down to um, the security and the encryption of the network, of the wireless network on the wireless side, and then the layer one basically security on the wired side. Um, so when you look at the wireless side with Wi-Fi, they're they either just ratified or getting ready to ratify a new WPA3 security mechanism for Wi-Fi. I think it's close if it hasn't been ratified already. But for the past 5 or 8 years, WPA2 has been the quote unquote unhackable security mechanism when used in conjunction with AES encryption. So that's again an IEEE standard for 802.11 communication. Um, but that combination of security and encryption is only as strong as the password you use for that network. So I'm sure you've used Wi-Fi. Either we're using it right now on our podcast. You plug in a name of a network you want to connect to, and you give it a password. And then if your password matches the password of the access point, you get on. Well, the way people hack those networks is they use what's called a library attack, and you can download libraries of passwords on the internet, and they just cycle through these passwords and try to see which one works. So if your password is 1234567, eventually that library is going to go through 1234567, and you're going to get online or get onto that network. So making sure your password is not something that's common. If you're going to use some kind of word, like Phoenix, for example. Don't use PHOENIX. Drop a zero in there. Have a special character. Put an underscore or a space, because now that the probability of that combination of characters being in somebody's library attack is very very low, minimal. Um, and then once you get past that, so that's the wireless portion of it, and on the radio itself, there are things like MAC address whitelisting and blacklisting. So going into the radio and going, hey, only people with these MAC addresses are allowed to connect once they pass the password and encryption portion of the authentication to the network. So if they get onto the network and their MAC address doesn't match this, boot them off. It's kind of a defense in depth type uh, um, setup. And then on top of that, on the background to back behind that, you can look at access control lists, or 802. one X radius server authentication, where your company has a list of names and MAC addresses on a server somewhere that your computer has to have a certificate and has to then, once it gets onto the network, go to the server has to authenticate it, and then it allows it on the network. So it varies from user to user. Most of the time, if you're just using a WPA2 AES encryption and you have a strong password, that's typically enough for most isolated applications. If you're out in the open and you're somewhere, you're out in the middle of a field or something where there's not as much physical defense to your network, you want to make sure you do a little bit more on the back end. Maybe once you get onto the wireless network and that Ethernet cable runs somewhere, you have another firewall or router or network security appliance that's filtering out data and doing some more checks in the background. That way, in case someone gets on your network somewhere out in the field, they can't get to the important parts of your network.
So once you've got all of this set up, and everything's up and running securely, what steps do you recommend to follow to ensure that the wireless network remains, stable and dependable as well as secure?
It's a good question, and that again comes back to my first comment: is make sure communication is open between all parties that are involved, whether that's their day to day, day to day they're involved with the wireless network, or they're working on another wireless network that's around your wireless network. To make sure that you're just not stepping on each other. You're you're playing nicely together in the sandbox. Making sure that all your devices are up to date on firmware. There are new vulnerabilities that are coming out every day. New ways of hacking networks, new way of getting malware on the networks. So working with your manufacturer, your vendor, to make sure that you're getting updates on new firmwares, new vulnerabilities they found in their own products. Making sure you're the most up to date product. So that you don't miss one and all of a sudden you're vulnerable to something that came out that you shouldn't be vulnerable to.
Well, thanks, Justin, and thank you for joining us for this podcast. Please keep watching this space for more installments of Automation World Get Your Questions Answered. And remember to visit our website at www.automationworld.com to stay on top of the latest industrial automation technologies insights, trends, and news.